Today we're going to talk about square roots. Before we can really get into square roots, we have to understand what it means to square a number. For example, if I want to square the number 4 to the second power, I would have to take the base number 4 and multiply it by itself. 4 squared is 4 times 4, which is 16. Another example would be 3 squared. 3 to the second power is 3 times 3, or 9. That's how we square a number. We take the base and we multiply it by itself. To undo squaring is to find the square root. To undo squaring is finding the square root. So, for example, the square root of 16 is the opposite of what we did up here. The square root of 16, I'm asking myself, what number do I multiply by itself to get 16? And that number is 4. So the question is, what do I multiply by itself to get 16? Now, the silly thing about square rooting is there are 2 things that I can multiply by themselves to get 16. I can multiply 4 by itself. 4 times 4 is 16. But I can also multiply -4 times -4 and get 16. If I'm looking for the negative solution to this problem, I simply put a negative outside my radical sign, and that's how I would know that I'm looking for the negative answer. The negative square root of 16 is -4, because -4 times -4 is positive 16. A little bit of vocab that might be helpful in this section. The number that comes inside is called the radicand. And this big check mark, almost like a division symbol, a little bit different, is called a radical sign. Let's try another one. The square root of 25. So my question this time is, what number do I multiply by itself to get 25? What number do I multiply by itself to get 25? The answer to that question is 5. 5 times 5 is 25. I could also find the negative square root of 25, because the square root of 25 is 5, and the negative of that is -5, because -5 times -5 is also 25. If I wanted both of these answers at the same time, I could simply write it in a way that would request both at the same time. If I wanted the positive and negative square root of 36, positive and negative, what number do I multiply by itself to get 36? And this time I want the positive and the negative. The positive and negative square root of 36 would be 6 and negative 6. Because 6 times 6 is 36, and negative 6 times negative 6 is 36. That's both the positive and the negative solution to this problem. As we work on square roots in class, it will be helpful to you to have a list of perfect squares. So I'm going to turn the page, and I'm going to make a list of perfect squares. Now, a perfect square gets its name because, hold on one second, perfect squares. Perfect squares get their number because if I were to draw a square, we know that all squares have side lengths that are exactly the same. So for example, this could be a 1 by 1, or a 2 by 2, 3 by 3, 4 by 4. When we're finding the area of a square, I'm going to start with a 2 by 2. If I were to find the area of this square, you can see that a 2 by 2 square has an area of 4. 2 squared is 4. If I had a 3 by 3 square, and I'm just breaking this up into smaller squares, this is a 3 by 3. To find the area of this square, I would do 3 times 3, or 3 squared, which is 9. These are perfect squares. So let's make a list of perfect squares. 1 squared is 1 times 1. 2 squared, 2 times 2. 3 squared, 3 times 3. 4 squared, 4 times 4. 5 squared, 5 times 5. And let's do our perfect squares all the way up through 10. You probably have the hang of this and you can fill these all in now. 6 squared, 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. I'm also going to write the inverse of this, the opposite. So if I were working backwards, the square root of 1 is 1, because 1 times 1 is 1. The square root of 1 is 1. The square root of 4, what number times itself gives us 4? 2. The square root of 9, what number times itself gives us 9? 3. So you can see that I'm really just working backwards. Instead of multiplying that base number times itself, I'm starting with my solution and working backwards. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. Square root of 81 is 9, and the square root of 100 is 10. I think it would be a great idea for you to keep this list going in your notebook, because as we start working with squares and square roots, this will be a helpful place for you to turn back to and use it as a resource. Okay, now that we know what square roots are, let's look at the steps for estimating square roots that are not perfect squares. So if we're not using a whole number and multiplying it by itself, then how do we find the square root of a number that's not a perfect square? For example, let's take a look at the square root of 18. Now, I would typically ask myself the question, what number do I multiply by itself to get 18? Now, the quick answer that people typically give is 9. But 9 times 9 is not 18. 9 times 9 is 81. If you think about all of those perfect squares that we listed earlier, there's no number on that list that I can multiply by itself and get 18. So we're going to go through the steps of how we estimate a number that is not a perfect square. The first thing we have to do is determine which two perfect squares does the square root fall between. Which two perfect squares does the square root fall between? So we want to think of this in terms of a number line. So I'm actually going to start a number line. I'm going to check my little cheat sheet back from the last section. If I look at this list of perfect squares, where do I find the square root of 18? Somewhere in here. Somewhere between 4 and 5. The square root of 16 and the square root of 25. The square root of 18 falls somewhere in there. So I'm going to make a number line that goes from 4 to 5, or from the square root of 16 to the square root of 25. All the way over to the square root of 25. Now I said the square root of 16 is 4, and the square root of 25 is 5. So I know that this is going to be 4 point something. It's somewhere in here between 4 and 5. Also, between the square root of 16 and 25, we have the square root of 17, the square root of 18, square root of 19, 20, 21, 22, 23, and I did not plan my spacing very well. If you tend to write out your number line, it will probably happen to you too. It's okay. So you can see that the square root of 18 is right here, between 4 and 5. I have to ask myself a couple of questions. How many total, I'll write it down for you, how many total square roots are there? And sometimes this is worded, it gets a little tricky. What I really want to know is how many jumps am I going to take? So I'll put that down here in parentheses. How many jumps? From the square root of 16 to the square root of 25. So I'm going to count those. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 total jumps to get from the square root of 16 all the way to the square root of 25. How many jumps to get to the square root of 18, or whatever it is that you're trying to estimate? In this case, 1, 2, and I'm actually going to do that in a different color, just so you can see the difference that I'm doing 2 different jumps here. So this is 1, 2. There are 2 jumps. So to find our decimal, because I know that it's somewhere between 4 and 5, I'm going to figure out what is the part of that whole. How far is this out of the total? Well, it's 2 out of 9 total jumps. 2 out of 9 total jumps. This isn't a decimal that most of you will probably be familiar with. So the best way, you can write out a division problem, or if your teacher lets you, you can go ahead and use a calculator. Students in my class will probably use a calculator because right now I'm not assessing whether or not you can divide 2 divided by 9, but what I'm really assessing is, can you estimate the square root of 18 by following these steps? So I'm going to take out my calculator and I'm going to do 2 divided by 9. And you can see that that decimal is 0.222222, or 0.2 repeated. So I'm going to write that down. 0.2 repeated. So the square root of 18 is not 0.2 repeated. It's not 0.2 repeated. Remember, it was between 4 and 5. It's actually 0.2 of the way between 4 and 5. So what I would say is that the square root of 18 is approximately 4.2. And that's how we estimate a square root. After you go through these steps multiple times, you'll start to get in the habit of counting how many total, how many to get to the number I'm looking for, and calculating this part out of the whole. It will become a habit. Let's try another one. Let's do the square root of, let's see, I'm trying to pick another one that will be on our list that we've already created. I'm actually going to scoot right over here so I have space to show you the next one. Let's find the square root of, how about 37? Let's estimate the square root of 37. There is not a number that I can multiply by itself to get 37. No number times itself will give me 37. So what I'm going to do is I'm going to pull out that list of perfect squares that you created earlier. And let's find on this list, where is the square root of 37? The square root of 37 is going to be between 6 and 7. It's going to come between the square root of 36 and the square root of 39. You can kind of visualize all of the numbers that fall in here. The square root of 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, and then you get to the square root of 49. They all fall between there. They're all 6 point something, and then we get to 7. So let's make a number line that goes from the square root of 36 to the square root of 49. square root of 36, which is 6, and the square root of 49, which is 7. Now let's fill in all of the square roots that fall in between here. Now I said them a second ago, and there's quite a few, so make sure you leave enough room. This is usually where I make a mistake and I don't give myself enough spacing. See, kind of ran out of room again. It happens. Eventually, you won't need the number line. It's just nice as you're starting out to have this visual. So I can see that the square root of 37 is right here. And I have those questions right over here on the right-hand side, so I'm going to follow those steps exactly like we did them last time. Which two perfect squares does it fall between? We've already figured that out. How many total square roots are there, or how many jumps from the square root of 36 to the square root of 49? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 total jumps between the square root of 36 and the square root of 49. How many jumps does it take me to get from the square root of 36 to the square root of 37? 1. It is 1 away from the square root of 36. And if you want to find that first, it might actually make it easier, because then you can write it part over whole without even having to flip those over. This is 1/3 of the way from the square root of 36 to the square root of 39. This might be a fraction that you're familiar with. 1/3 is 0.3 repeated. So the square root of 37 is not 0.3. Remember, we're between 6 and 7. This is 1/3 of the way. So it's actually 6.3, approximately. I want to do one more example, and this time we're actually not going to draw out the entire number line as a visual. We're still going to do this calculating the jumps. We're just going to do it a different way. So this time let's think about the square root of, how about the square root of 5? The square root of 5. If I take my perfect squares list, which two perfect squares does the square root of 5 fall between? Well, I can see that it would be right in here between the square root of 4 and the square root of 9. So I'm going to write down that it's between the square root of 4 and the square root of 9. It's between 2 and 3. Square root of 4 is 2. Square root of 9 is 3. Now, another way to find all of these jumps is to simply find the difference. Finding the difference is subtracting. So from the square root of 4 to the square root of 9, I'm just going to subtract 9 minus 4, and that will give me how many jumps there would be in between. And there are 5. If I'm going from the square root of 4 to the square root of 5, 5 minus 4, 5 minus 4 is 1. So this is 1/5 of the way, part out of whole, 1/5 of the way between the square root of 4 and the square root of 9. 1/5 as a decimal is 0.2. So the square root of 5 is approximately, between 2 and 3, 2.2.